Circadian rhythm. Have you ever noticed that you feel more alert at certain times of day, and feel more tired at other times? Those patterns are a result of two body systems, sleep or wake homeostasis and your circadian rhythm, or internal body clock. These systems determine your sleep drive, or your body's need for sleep, at any given time. Homeostasis describes a state of equilibrium between different elements of an organism or group. Sleep or wake homeostasis balances our need for sleep, called a sleep drive or sleep pressure, with our need for wakefulness. When we've been awake for a long period of time, our sleep drive tells us that it's time to sleep. As we sleep, we regain homeostasis and our sleep drive diminishes. Finally, our need for alertness grows, telling us that it's time to wake up. If sleep or wake homeostasis alone regulated our sleep drive, we'd likely find ourselves yo-yoing between sleep and alertness throughout each day. Your biological clock, or circadian rhythm, governs the body's physical, mental and behavioral changes over each 24-hour cycle. Chronic misalignment of your circadian rhythm can lead to various physical and mental disorders. They include obesity, type 2 diabetes, cancer and cardiovascular diseases. Regular exposure to sunlight, staying active during the day, avoiding caffeine and reducing exposure to artificial light before bedtime can help synchronize your internal clock. Anyone who has suffered from jet lag or struggled after turning the clock forward or back an hour for daylight saving time knows all about what researchers call your biological clock. It is called circadian rhythm, the master pacemaker that synchronizes how your body responds to the passing of one day to the next. This clock is made up of about 20,000 neurons in the hypothalamus, the area near the center of the brain. It coordinates your body's unconscious functions, like breathing and blood pressure. Humans aren't the only beings that have an internal clock system. All vertebrates, or mammals, birds, reptiles, amphibians and fish, have biological clocks, as do plants, fungi and bacteria. Biological clocks are why cats are most active at dawn and dusk, and why flowers bloom at certain times of day. Circadian rhythms are also essential to health and well-being. They govern your body's physical, mental and behavioral changes over each 24-hour cycle in response to environmental cues like light and food. They're why more heart attacks and strokes occur early in the morning. They're also why mice that are missing their biological clocks age faster and have shorter lifespans, and people with a mutation in their circadian clock genes have abnormal sleep patterns. Chronic misalignment of your circadian rhythm with external cues, as seen in night shift workers, can lead to a wide range of physical and mental disorders. In short, there is ample evidence that your biological clock is critical to your health. How biological rhythms work. Your biological rhythms are tied to an internal clock in your brain called the suprachiasmatic nucleus, SCN. It is located in your hypothalamus. This is the area of your brain that manages the autonomic nervous system and the pituitary gland. SCN, suprachiasmatic nucleus. Your SCN sends signals throughout the day to regulate your body's activity. In cycles, most biological rhythms work in roughly 24-hour cycles. Others, such as menstrual cycles, work over longer time frames. Each type of biological rhythm has a certain name to show how long it lasts. Diurnal, night and day. Circadian, 24 hours. Ultradian, less than 24 hours. Infradian/circalunar, 1 month. Circannual, 1 year. Circadian and diurnal rhythms, which control functions like sleep, body temperature, and hormonal changes, are most affected by light. Sunlight tells your SCN what time it is and when to perform certain functions. Other factors that influence your internal clock are exercise, hormones, and any medications you might be taking. Studies have shown the power of the internal clock by placing people in environments without the cues necessary for their circadian rhythms. Even without light cues, your SCN can maintain your body's processes for a time with only slight deviations in its normal 24-hour rhythms. Individual chronotypes. If your internal clock is so powerful, then why is it so hard to wake up in the morning? This is due to a circadian pattern called your chronotype. It is the biological tendency to deviate from a 24-hour cycle. Night owls and early birds, studies have also shown how the body's circadian rhythms continue even in total darkness. Even without any light, people's individual rhythms deviated only slightly from a strict 24-hour cycle. The population's circadian cycles ranged on average between 23.5 hours and 24.6 hours. These deviations are due to people's personal chronotypes. Researchers believe them to be the cause of people being either an early bird or a night owl. How biological rhythms affect your health. Your biological clock affects your health by regulating your sleep-wake cycles and fluctuations in blood pressure and body temperature. It does this primarily by syncing your endocrine system to environmental light-dark cycles so that certain hormones are released in certain amounts at certain times of day. The pineal gland in your brain, for example, produces melatonin, a hormone that helps regulate sleep in response to darkness. Doctors advise reducing exposure to artificial blue light from electronic devices before bedtime because it can disrupt melatonin secretion and sleep quality. Your circadian rhythm also affects your metabolism. Among other things, sleep helps you regulate leptin, a hormone that controls appetite. Your leptin levels fluctuate throughout the day according to a rhythm set by your circadian clock. Insufficient or irregular sleep can disrupt leptin production, which can make us hungrier and lead to weight gain. Hormones. Your hormones fluctuate rhythmically over the course of the day. In recent years, researchers have discovered even more ways your circadian clock can affect your health. For example, there is now research suggesting that eating at set times of day, or time-restricted feeding, can prevent obesity and metabolic diseases. Depression and other mood disorders may also be linked to dysfunctional circadian control that leads to changes in how your genes are expressed. The time of day when you take your medicine can also affect how well it works and how severe any side effects might be. Likewise, your biological clock is a potential target for cancer chemotherapies and anti-obesity treatments. And finally, even your personality might be shaped by whether your internal clock makes you a morning person or a night person. Getting the most out of exercise. Circadian clocks also provide a potential answer to when is the best time of day to maximize the benefits of physical exercise. Circadian clocks may also provide the answer to when the best time of day to exercise is. Early morning exercise reduced blood glucose levels more than late evening exercise. Exercise in the late evening, however, allowed the mice in a study to benefit from energy they stored from their meals and increase their endurance. Exercise affects your health and, if timed appropriately, can be optimized based on time of day to meet your personal health goals. Regular exposure to sunlight triggers the endocrine system to produce vitamin D. Stay active during the day so you fall asleep more easily at night and avoid caffeine and reduce your exposure to artificial light before bedtime. Biological clocks are fundamental to the functioning of life and to the organization and coordination of behavior. Simple behavioral functions, such as timing active and inactive periods during the day or night cycle to maximize productivity and minimize risk, rely on internal clock functions. The early recognition by de Morane of the existence and functioning of biological clocks, followed by Askovsky investigations in the mid-1900s. This has led to knowledge of the genetics underlying biological clocks, into how they are set, and into how clocks regulate physiological and behavioral processes. The existence of the biological clock can be particularly apparent when it's off-kilter. Jet lag and shift work can throw our normal patterns out of whack and take a toll on physical and mental health. Even shifting the clock an hour forward or backward when daylight savings time begins or ends can disrupt our biological clocks. Disrupting our body's natural cycles can cause problems. Studies have found there are more frequent traffic accidents and workplace injuries when we spring forward and lose an hour of sleep. Heart patients are at greater risk for myocardial infarction in the week following the daylight savings time shift. There are important connections between a disrupted clock and chronic health issues, from diabetes to heart disease to cognitive decline. It turns out that the same genes and biological factors that govern our internal clock are also involved in how other body systems operate and break down. It can be hard to determine whether a disrupted clock leads to health problems, or whether it's the other way around. But genes also influence the body's clock and circadian rhythms. The system requires both types of input, light and genes, to keep it on track. 24-hour cycle. To stay on the 24-hour cycle, the brain needs the input of sunlight through the eyes to reset it each day. When humans are allowed to run off their body's clock apart from input from the sun, by being kept in continuous darkness, the body's daily cycle tends to lengthen to about 25 hours. Melatonin is one hormone responsible for our body's daily cycle. When night falls and there is less light input to the SCN, the production of melatonin, the hormone responsible for making us feel sleepy, goes up. When it's dark, more melatonin is secreted, which signals the brain to go into sleep mode. When the sun rises, melatonin secretion is inhibited, and the brain's awake circuits resume. Other systems also follow a daily rhythm, many of which are controlled by hormones and other compounds that receive cues from the biological clock. For example, the hormones responsible for hunger and metabolism rise and fall over the course of the day. The chemicals involved in immune system function also vary. This is likely because the body is better at fighting infection while it is at rest, and energy can be poured into the effort, rather than into other functions. And activity of the stress response system, particularly in secretion of the stress hormone, cortisol, is reduced during the nighttime hours, and heightened in the early morning. There are certain areas of the body, like the heart, that are able to govern their own function to some degree. But there is strong evidence that the body clock plays a major role in controlling many of these fluctuations, such as in blood sugar, over the 24-hour period. When jet lag sets in, we feel disoriented, foggy, and sleepy at the wrong times of day. It is because, after changing time zones, our body clock tells us it's one time and the outside environment tells us it's another. In fact, jet lag can be considered one type of circadian rhythm disorder. People who work the night shift have a hard time with their sleep patterns, feeling sleepy at work or experiencing insomnia during the day. But other systems in their bodies can also feel the effects, and they can be chronic. It's not been clear exactly why this connection exists, but weight gain or metabolic changes may be involved. The same genes that control the receptors for the sleep hormone melatonin are involved in insulin release, which could also play a role in diabetes risk. Heart problems like fatal arrhythmias are more likely to occur at certain times of the day, both in the early morning and to a lesser degree, in the evening hours. Taking blood pressure medication in the evening seems to improve its effectiveness because it works with the body's circadian rhythms. The reason for this has recently become clear. A genetic factor involved in the rhythm of the brain's clock also controls the electrical activity in the heart. Mice who are bred to lack this factor, cripple like factor 15, KLF15, or have too much of it, have many more heart problems than normal mice. Certain chemicals responsible for immune function, like cytokines, wax and wane throughout the day, and sleep deprivation deprives us of their best effects. The circadian rhythm mental health connection has also been linked to disease states like Alzheimer's, Parkinson's, and Huntington's, and even autism spectrum disorder. Our body's clocks can go out of sync, and they may involve a combination of genetic predisposition and lifestyle choices, such as alcohol consumption. The clock can get unset, as with the changes associated with daylight savings time, air travel, or shift work. There's only so much we can do until our body and its clock are in equilibrium again. Does sleep drive change as we age? For most people, circadian rhythm changes at 3 key points in our lives: during infancy, adolescence, and old age. When babies are born, they haven't developed a circadian rhythm yet. A newborn baby's sleep cycle requires up to 18 hours of sleep, 7, broken up into multiple short periods. Babies develop a circadian rhythm around 4 to 6 months of age, at which point they tend to sleep in larger blocks of time. In adolescence, up to 16% of teenagers experience a sleep phase delay. Due to this circadian shift, their melatonin levels don't begin to rise until later in the evening. As a result, they naturally feel more alert at night, making it harder for them to fall asleep before 11 p.m. This wouldn't be a problem if school start times weren't so early, which makes it tough for teens to get the recommended 8 to 9 hours of sleep per night. With less sleep, teenagers may experience trouble staying focused during school. Our sleep drive changes again as we age into our senior years. As aging occurs, the internal sleep clock begins to lose its consistency. Older adults tend to become tired earlier in the evening and wake up earlier in the morning, resulting in less sleep overall and increasing the risk of cognitive decline. Seniors experiencing Alzheimer's, dementia, or other neurodegenerative diseases experience even more severe changes in sleep drive. What are the effects of biological rhythm disorders? Anxiety, daytime sleepiness, depression, lower performance at work. Being more accident-prone, lack of mental alertness, increased risk for diabetes and obesity. Some of the world's most significant human errors have happened during night shift work. These include the Chernobyl disaster and the 3 Mile Island accident. Also, most single-driver accidents occur in the time before dawn, according to Cornell University. From a brain and body perspective, our bodies are made to sleep at night. This is why we don't have adaptations like night vision and an enhanced sense of smell and hearing like nocturnal animals do. How is biological rhythm disorders treated? When lifestyle treatments and good sleep hygiene don't work, your doctor may prescribe medication. Modafinil, Provigil, is for people who have difficulty with daytime wakefulness. Your doctor can also prescribe sleep medicines as an option. But sleep medications should only be taken on a short-term basis. What can I do at home to relieve biological rhythm disorders? Avoid substances known to affect sleep right before bed. These could include caffeine, alcohol, and nicotine. Drink very cold drinks like iced tea or water. Keep a regular sleep schedule whenever possible. Take a brisk walk outside during daylight hours. Take a brief 10 to 15 minute power nap. Turn on more lights inside your home during the day. Conversely, turning the lights low or off at night can enhance sleepiness. It's important to remember that your biological rhythms are intended to protect you. They signal when it's time to rest. And they assist you in the morning and early evening in being your most productive. You'll get the most benefit in your day-to-day life when your biological rhythms are in sync.